operations with complex numbers. If we have a complex number in rectangular form, like this one here, and another complex number in polar form, we are only going to be able to operate with them if they are in the same form. So we would need to change the rectangular form into polar form, or we would change the polar form into rectangular form. So before we start any operations with complex numbers, we do check if they are in the same form. Once we check that they are, then we can proceed. So what do we do if we have a multiplication? So Z1 times Z2. What's the ideal form for multiplication? Well, we could use either rectangular form or polar form. But polar form has a very quick and easy way, and it's preferable for multiplication, including division as well. If we were to add these two complex numbers, then the best would be, well, the only possible way would be to use rectangular form. We cannot add or subtract complex numbers in polar form. So another exercise would be to do a more complex operation by multiplying Z1 by Z2 and dividing that answer by Z1 added to Z2. So of course then we probably will have converted Z1 into polar form to match with Z2 for the multiplication, and then we would have converted Z2 into rectangular to add on the bottom, so they would be different again. So it means we would need to change either the green or the pink one, so the polar into rectangular or rectangular into polar, to be able to do the final calc. And because this final calc is actually a division, a quotient, the best way would be to actually keep polar form for both. So in a problem like this one here on the bottom, and we could have rewritten it like that, Z1 times Z2 divided by Z1 plus Z2, the best thing to do first is to change each one of the complex numbers into the other form. So let's start by changing the original Z1 into polar form. Well, we know that this 10 here is the A, the real part of the number, 5 is B, the imaginary part of the number. To write this in polar form, we need the R, the magnitude or the length, the radius, and the angle or argument theta. So we know that there is a formula for this R just based on Pythagoras. So it will be a squared plus b squared and then square rooted. So in this case we have 10 squared plus 5 squared and square rooted. So 125, and we need the square root of that, which is 11.2. So that's the magnitude. Then we have to calculate the angle theta, which is calculated by using trigonometry in the right angled triangle, tan inverse of b over a. So the angle will be 5 over 10, tan inverse of that, which we get 26.6 degrees. So now we are ready to rewrite Z1 that we had originally there on the top as a rectangular representation, 10 plus J5, into polar form, R, and the angle 26.6 degrees. Here it is. That's Z1. Then the next stage would be to convert Z2 that was originally in polar form. We should convert this into the rectangular form A plus JB. What do we know here? 20 is the R and 30 degrees is angle theta. So we go from polar to rectangular via the trigonometric form. So we would say Z1 is the radius multiplied by the cosine of the angle plus J times sine of the angle, which I have already written as 30 degrees. So let's replace the r with that 20. And then, of course, we need to expand 20 times the cosine of 30 degrees, 20 times sine of 30 degrees. Once we do that calculation, we get 17.3 for the real part, or A, and we get 10 for the imaginary part, or B. So now we have both Z1 and Z2 rewritten in rectangular and polar forms, basically the two forms for each one of them. So the first calc we had to do was Z1 times Z2. Well, multiplication, we choose polar form, always the easiest way. So Z1 was 11.2 with an angle of 26.6 degrees, and we have to multiply that by Z2, which was 20 and an angle of 30 degrees. Now here is where multiplication with polar form is really easy. The magnitudes we multiply, so we would do 11.2 times 20. The angles we don't multiply, we simply add them. So 26.6 plus 30, both in degrees. So let's see what we get for 11.2 times 20. So we get 224 is the new magnitude, or R, and 26 plus 30, we get 56.6 degrees is the argument. So this is the product of Z1 and Z2. 224, 56.6. So the next task will be to add Z1 and Z2. So addition, the best way will be rectangular form. So we're gonna get Z1 in rectangular form was 10 plus J5, and we want to add that to Z2. We converted into rectangular form as 17.3 plus J10. So now how do we add in rectangular form? We add the real part with the real part. So we're gonna have 27.3, and then we're going to keep the J there, and we add the imaginary part with the imaginary part. So 5 and 10, 15. So this is the answer in rectangular form for the sum of Z1 and Z2. Our final answer actually required Z1 times Z2 divided by Z1 plus Z2. So we got the top answer in polar form. 224 was the magnitude, 56.6 degrees was the angle, and the sum we've just calculated as 27.3 plus J 15 in rectangular form. So again here we have two different forms. Top one is in polar form, bottom one is in rectangular form. They have to be the same. So what are we going to choose? Because this is a quotient division, the best way to divide complex numbers will be to use the polar form. So the top one is already good, it's in polar form, but it means we have to do all the work with the number on the bottom, 27.3 being the real part, 15 being the imaginary part, and we'll need to find the r and the theta, the magnitude and the angle. So we do that work. So r equals a squared plus b squared, so 27.3 squared plus 15 squared, and we get that answer. So square both, add them together, and take the square root of that. So 31.1 if we round to one decimal place. Now for the angle, we know it's tan inverse of b 15 over a 27.3. So let's do that calculation. Tan inverse of 15 divided by 27.3. Make sure your calculator is set to degrees. So we get 28.8 degrees. Just double checking. Shift inverse to get the inverse tan. Open brackets if your calculator doesn't do that straight away. Divide by 27.3, close brackets, 28.8 degrees. So that means these are the two elements we need for the polar form. So it means that green number on the bottom now can be replaced with 31.1, angle 28.8 degrees. And I'll just rewrite the fraction line or division line and copy the top number. That was 224.56.6 degrees. So the final step now is to divide those two. So how do we divide two complex numbers in polar form? We do divide the the radius or the magnitudes. So 224 divided by 31.1, and we're going to bring that answer right here. So 7.2. So this is our new R. Then the two angles 56.6 and 28.8 we are not going to divide, we are just going to subtract. And then the angle that we get is 27.8 degrees. So final answer, 7.2 being the argument, the magnitude, and 27.8 degrees being the argument or the angle. All we've done here was we wanted to calculate that, the quotient of the product of two complex numbers by the sum of two complex numbers. They were given to us in different forms, so we had to change both to the other form and then use the best form for each of the operations. Just recapping, multiplication and division of complex numbers will be faster, easier if we use polar form. For adding or subtracting complex numbers, we must use the rectangular form.